Hi guys, so this is 3.2. In this section, we are just going to be talking about parallel lines and transversals. We're going to have two little videos for this section. We are going to prove theorems about parallel lines in this little video. And then in the second 3.2 video, we are going to be solving problems, solving variables and diagrams using the theorems that we are going to introduce in this video. Okay, so watch both and bring any questions to our classes, okay? The vocab is just going to be the new theorems and postulates that we introduce on the next slide, okay? You guys are going to notice that these new theorems and this postulate, look at their names. The alternate interior angles theorem, consecutive interior angles theorem. There are special angle pairs, okay? The angle pairs that we talked about in 3.1 have theorems and postulates made about them, okay? And it's very obvious, and it only occurs when we are working with parallel lines, okay? So notice I have two lines being cut by a transversal, which then creates these special angle pairs, and we are going to introduce them and look at an example with each one. So the first theorem we're going to look at are alternate interior angles. We know alternate interior angles are on the inside of the lines on alternate sides of the transversal. So they're just telling us before we even read the description, we can tell from 3.1, we're super great at this, we can tell that angles 3 and 6 are alternate interior angles, okay? So notice them, right? What do they have in common? Looking at their size, looking at their angle measure, we can say that alternate interior angles are congruent, okay? Check out 3 and 6. They're both acute angles, and if we have parallel lines being cut by a transversal, then my alternate interior angles are congruent, and that's what this theorem tells me, okay? The same thing would be true about 4 and 5, if you're wondering, because 4 and 5 are also alternate interior angles. Notice those angles. They are also congruent. They would both be supplementary, okay? I'm sorry. They would both be obtuse angles. So they are congruent, okay? Not supplementary. Oh my goodness. Kind of looked ahead here. All right, let's talk about the next one. Consecutive interior angles. Consecutive interior angles are, let's check out 3 and 5. Angles 3 and 5 are consecutive. They're on the same side of the transversal, and they're on the interior of my two lines. Check out 3 and 5. This is where I was talking about supplementary. 3 is an acute angle. 5 is an obtuse angle. They are supplementary angles. The theorem states that when we have consecutive interior angles, they are supplementary. So I can say measure of angle 3 plus measure of angle 5 is 180 degrees. They are supplementary. Same thing would go for angle 4 and 6. I have an obtuse angle and acute angle. The reason I'm talking about the classifying the angles is because it makes sense, right? If you're trying to find alternate interior angles and you're for maybe thinking alternate interior are 3 and 5, well, 3 is definitely not congruent to 5 for the reason 3 is acute, 5 is obtuse. So no way I can say they're congruent. And now, vice versa, it makes sense to say that angle 3 plus angle 5 equal 180 because I have an acute and obtuse. So looking at classifying them is going to help us verify these theorems. And our next example says we're going to be looking at alternate exterior angles. So 1 and 8, right? These guys are so far apart from each other. Just looking at 1 and 8. Right? I notice they're both obtuse. When we can say alternate exterior angles are congruent when two parallel lines are cut by a transversal. Right? Angle 1 looks the same angle measure as angle 8. They are congruent. And lastly, what do you think we can say about corresponding angles? Let's look at angles 1 and 5. We know they're corresponding. They're on the same position at the intersection points. We can say that they are congruent. Corresponding angles are congruent. Okay, so the reason I keep pointing out the diagram is because it makes sense when we look at it. Of course it looks like 1 and 5 are congruent. They look exactly the same. They're twins, right? We want to look at the diagram and help it make sense. Okay, I'm going to show you the proof of alternate interior angles, and we're going to complete this together. We are given that line L is parallel to line M, and we can tell that we have those little notations on here. We want to prove alternate interior angles are congruent, 4 and 6. I want to give you guys a little trick here. Alternate interior angles, if those, I have my lines, my parallel lines, and they're cut by this transversal, what letter does that look like? It looks like a Z, right? A Z. It tells me, here's a way that to figure out that those angles are congruent. Check out 4. If you can make a Z, we have alternate interior angles. Okay, but why are they congruent? Why can I say they're congruent? Let's complete this proof. So we always start with our given. Line L is parallel to line M. Angle 2 is congruent to angle 4. What do I know? What theorem tells me that angle 2 is congruent to angle 4? Goes back to chapter 2. What theorem tells me that 2 is congruent to 4? Hopefully you're thinking it's the vertical angle theorem, right? They're vertical angles. It all ties together, guys. Now, why can I say 2 and 6 are congruent? This guy and 6. 2, angle 2, and angle 6 are congruent. Check out their positions, right? Are they in the same position? Absolutely. So corresponding angles postulate tells me that they are congruent. So now check out my statements. How can I all of a sudden say angle 4 is congruent to angle 6? Hopefully you're thinking the transitive property. Look, they're both congruent to angle 2, which means 4 and 6 are congruent. Okay, this is a little proof tying everything together, proving alternate interior angles are congruent. Okay, well, I'm going to pause this video here. You guys are going to watch the second part, and this part, the second part, is so cool. We are solving diagrams for variables. Get ready.